students, today we are going to learn about time shifting property of Z transform. Time shifting property means the property which will give us the explanation of if we shift the time domain signal, what will happen to the respective Z transform. Means if we are having a time domain discrete signal xn with the Z transform xz, and if we shift this time domain signal, then according to the time shifting property of the Z transform, x of z means Z transform will be multiplied with z to the power minus k. Here k is some constant. So, according to the time shifting property, if we shift our signal in time domain by some constant k, then the Z transform will be multiplied with z to the power minus k. Now, we will prove this property. So, for proving this property, we will start with the equation of xz, which is summation n is equals to minus infinity to plus infinity xn z to the power minus of n. Now, if we want the Z transform for xn minus k, because this is the Z transform of xn. So, if we want the Z transform for xn minus k, we have to replace this xn by xn minus k. So, the equation will become summation from minus infinity to plus infinity xn minus k z to the power minus n. Now, we will replace the variable n minus k by m. So, we can put n is equals to m plus k. Now, we will do these two replacements in this equation. So, now the limit of summation which was previously with respect to n, now it will become with respect to m. So, summation m. Now, n is moving from minus infinity to plus infinity. So, m will have the value from minus infinity to plus infinity. xn minus k. n minus k is m. So, we can write here xm. Z to the power minus n, we can put m plus k in the place of n. So, we are going to put here m plus k. Now, the equation is summation from m is equals to minus infinity to plus infinity xm z to the power minus m plus k. Now, we can rewrite this equation as m is equals to minus infinity to plus infinity xm z to the power minus m z to the power minus k. So, we can write x dash z, which is the Z transform for xn minus k, which is the Z transform for xn minus k, will be equal to, in this equation as we can see, the summation is with respect to m. So, this z to the power minus k will behave as a constant. So, we can put it outside the summation like this. Now, the rest of the equation is m from minus infinity to plus infinity xm z to the power minus m. So, this equation m minus infinity to plus infinity xm z to the power minus m will give us this Z transform xz. So, we can put this xz in this in the replacement of this complete equation. So, x dash z will become z to the power minus k xz, or Z transform of xn minus k will be equal to z to the power minus k xz. So, how we have proved it? Z transform of xn is given by this equation. So, now we will replace and put xn minus k in the place of xn. So, we will get this equation. Then we have replaced the variable n minus k by m. So, n is equals to m plus k in this equation. Then we found this is summation m minus infinity to plus infinity xm z to the power minus m plus k. Then we have split it into the two functions, that is z to the power minus m and z to the power minus k. Now we find this equation, and in this equation we can keep this z to the power minus k outside of the summation as it is free from variable m. So we find, or we can say we have rearranged this equation as z to the power minus k outside the summation. Inside the summation we are having x m z to the power minus m. Now when we compare this complete equation with the equation of z transform, that is this, so we can write this in the place of this complete equation, we can write x z. So x dash z, that is the z transform of xn minus k, that is z to the power minus k x z. So this property is proved. Now how to use this property? We are taking an example. Suppose we have to find the z transform for un minus 3. This is our signal xn and we have to find the z transform for un minus 3. So we know the z transform of un is z upon z minus 1. Z transform of un is z upon z minus 1. So un is having the z transform of z upon z minus 1, then un minus 3 according to the time shifting property. Now the value of k is 3. So un minus 3 will have the z transform as z to the power minus 3 xz. Xz is z upon z minus 1. So after the simplification we will get 1 upon z square z minus 1. So this will give us the z transform for un minus 3. Or we can take another example. This was the first example. Suppose we have to find the z transform for 2n minus 1 un minus 1. Now the base function on the basis of which we are going to calculate the rest of the things is 2 to the power n un. As we can see, the function which is asked in the numerical is 1 unit shifted. 1 unit shifted signal when the base signal is 2 to the power n un. So 2 to the power n un is having the z transform as z upon z minus 2. So after the 1 unit shift n minus 1 un minus 1, the z transform will become z inverse. Now the value of k is 1. So this will become z inverse z upon z minus 2. So after this multiplication we will get 1 upon z minus 2. So the z transform for 2n minus 1 un minus 1 is 1 upon z minus 2. So this way we can use time shifting property.